How much of what we know about the surface of Venus comes from machines that died, on average, in under an hour? All of it. Every photograph, every soil sample, every recording of the wind, captured by a handful of Soviet landers that survived just long enough to transmit and never replaced. The most recent died in 1982. So why did we stop going back to the one planet we'd actually managed to touch? For 40 years, we were told Venus was a dead world, a failed Earth, too hot, too crushing, too finished to bother with, a planet with nothing left to say. Every word of that was wrong. To understand why, you first have to understand what we sent those machines into. Start with the heat. The surface of Venus sits at roughly 465 degrees Celsius. Not at noon, not at the equator, everywhere. Pole to equator, noon to midnight, the temperature barely moves. That is hot enough to melt the lead in a car battery, the tin in old solder, the zinc in a coin, across the entire planet in the dead of night. The atmosphere holds so much heat that there is no cool side to run to. There is no night side cold enough to survive. Then there's the pressure. At the surface, the air pushes down at about 92 bar, roughly 92 times what it does at sea level on Earth. NASA puts it plainly. Standing on Venus, the air alone presses on you as hard as the ocean does about 930 meters down, deeper than a submarine's crushed depth. And that's before the heat touches you. Now the chemistry. The atmosphere is 96.5% carbon dioxide, wrapped in a permanent cloud deck of concentrated sulfuric acid, kilometers thick, circling the whole planet. Any lander has to fall through an acid bath before it ever reaches the furnace. And one more thing, the strangest of all. Down at the surface, the carbon dioxide stops behaving like a gas. The pressure and heat push it across a line into something called a supercritical fluid. Dense, flowing, more like a liquid than air. So you wouldn't feel a breeze on Venus, you'd feel resistance, like wading through a hot, invisible sea that covers the entire planet. A machine landing there isn't touching down in air, it's sinking into a fluid. And no, none of this is because Venus is close to the Sun. Mercury is closer, and Mercury freezes at night. Venus is this hot because its own air traps heat and never lets it go. It's a runaway greenhouse. A warning, not a coincidence. This is what the Soviets chose to send machines into. Not Mars, not the Moon. The one world built to destroy them on contact. And yet, between 1970 and 1982, something kept landing there anyway. For more than 20 years, the Soviet Union threw probe after probe at Venus, while NASA aimed for Mars. They called the program Venera, and in the beginning, Venus won every time. The early landers were crushed in mid-air. Engineers kept underestimating the pressure, and the planet kept folding their spacecraft like tin cans before they ever reached the ground. Then, on the 15th of December 1970, Venera 7 became the first machine in history to transmit from the surface of another planet. It barely made it. The parachute partly failed. The craft hit hard and toppled over. The signal came back so faint that engineers nearly dismissed it as tape noise. We almost threw away the first words ever spoken from another world. But it was real. About 23 minutes of telemetry, confirming the furnace was exactly as deadly as they'd feared. 5 years later, Venera 9 and 10 sent home the first photographs ever taken from the surface of another planet. Flat, plated rock, barely eroded. The face of a young, waterless world. Venera 9 lasted 53 minutes before the heat took it. At the time, that felt like an eternity. And then came the one that still has no equal. Venera 13, the 1st of March 1982. It returned the first color panoramas of the Venusian surface. And they are still the only ones in existence. Look closely, because these are not paintings. They are not an artist's guess at what Venus looks like. They are real photographs, scanned line by line through red, green, and blue filters by a machine that was dying as it took them. That same probe drilled into the ground and analyzed the soil, volcanic rock, a basalt, the signature of a world made by fire. But the most haunting thing Venera 13 brought back wasn't a picture. It was a sound. Venera 13 and 14 carried microphones built to survive the heat and the pressure. They recorded the first audio ever captured on another planet. The snap of the lens cap firing off, the grind of the drill, and underneath it, a low howl, the wind. From that sound alone, physicists worked backward and measured the breeze on Venus. Barely half a meter per second, the pace of a slow walk. But in air 90 times denser than ours, even that gentle current carries the weight of a deep ocean swell. And then there is the detail no conspiracy would ever invent. When Venera 14 fired off its lens cap, the cap landed, out of an entire planet's worth of ground, on the exact patch its soil strength probe was about to test. The Soviets, by pure chance, measured the hardness of their own lens cap. You don't script that. You only stumble into it. Venera 14 itself held on for 57 minutes, long enough to confirm a second kind of volcanic rock at a second site. Then it too fell silent. Now, remember the question we started with, how long these machines lasted. Venera 7, 23 minutes, Venera 9, 53, Venera 14, 57, and Venera 13 was built to die in 32 minutes. It transmitted for 127, the longest any machine has ever survived on the surface of Venus, nearly 4 times its own design life, fighting a planet engineered to kill it on contact. And then it cooked from the outside in and went silent. That record has never been broken, not by NASA, not by anyone. The most recent surface mission died in 1982. Everything humanity knows about standing on Venus is frozen in that single year. And then we walked away, for 40 years. The question is why, and the honest answer is stranger than any cover-up. After the early Mars missions, NASA poured its resources into the Red Planet. Mars offered ancient riverbeds, a possible habitable past, a story people could love. Venus offered only hell. One planetary scientist, Stephen Kane, put the institutional logic bluntly. Would you want to build your house over a pit of sulfuric acid? So they didn't. After the Magellan orbiter mapped almost the entire surface of Venus with radar, it burned up in the atmosphere in 1994. After that, NASA flew no dedicated mission to Venus for nearly 30 years. Venus's own scientists submitted proposal after proposal. They were passed over. For Mars rovers, for missions to the outer planets. Venus got filed away as the failed sister, useful only as a cautionary tale about runaway heat. That is the part the title points toward. And this is the honest version of it. This was not a cover-up. Nothing was classified. The Venera data was shared across the Iron Curtain at the height of the Cold War. American researchers studied Soviet radar through joint programs. The neglect was structural. Budgets, priorities, inertia, not malice. Nobody hid Venus from us. We just stopped looking. And the clearest proof of that sits in NASA's own archive. Back in 1978, a NASA probe called Pioneer Venus measured the chemistry of the atmosphere in detail on its way down. The team logged the common gases, then the trace data,
the faint and difficult readings sat in obscure legacy tables. For 42 years. When a team finally reran those numbers with modern tools, they found signatures of chemistry that should not be able to coexist. A planet's atmosphere caught far out of balance. The kind of disequilibrium that demands an explanation. All of it overlooked since the year the first Star Wars film was still new in theatres, including a trace of something that would decades later turn Venus back into the most argued about planet in the sky. It took one borderline sensational claim to finally break the silence.
September 2020, a team led by astronomer Jane Greaves announced they had detected about 20 parts per billion of a gas called phosphine in the clouds of Venus. On Earth, phosphine comes almost only from two sources: industry or anaerobic microbes, living things in places without oxygen. And the team could find no ordinary chemistry on Venus that should produce that much of it. So the headlines were already waiting. For a moment, the dead planet was alive. And then the careful work began, and the life claim started to come apart. The first crack was altitude. In 2021, a team including Victoria Meadows showed the signal wasn't coming from the temperate cloud layer where microbes might float. It traced higher up, into a region where solar ultraviolet light tears phosphine apart in seconds, which led to a brutal number. To keep 20 parts per billion alive up there, against that destruction, something would have to be pumping phosphine into the sky at roughly 100 times the rate that all the photosynthesis on Earth produces oxygen. 100 times every plant and every ocean on our planet. That isn't a colony of microbes. That's impossible. Then, independent teams reanalyzed the data and found the signal was better explained by ordinary sulfur dioxide, a common Venusian gas whose fingerprint overlaps almost exactly with phosphines. And a separate search found no phosphine at all. But, and this matters, the story refuses to die. In 2024, two more teams reported a tentative redetection of phosphine deeper in the atmosphere, alongside hints of ammonia. So be precise about what actually happened here. The claim of life on Venus collapsed. The molecule itself, still contested, still unresolved. And if any phosphine really is down there, the better supported explanation isn't life floating in the clouds. It's something erupting underneath them. In 2021, researchers at Cornell, including Jonathan Lunine, worked out the only realistic way to make phosphine on Venus without life. Explosive volcanism. Deep eruptions flinging up minerals from the mantle fast enough to react in the clouds before they're destroyed. As Lunine put it, the phosphine is not telling us about the biology of Venus, it's telling us about the geology. But the model needed one thing to be true. Venus had to be erupting today, and nobody had proof. The whole idea rested on a planet everyone called dead, because that was the consensus. Venus is almost Earth's twin, same size, same heat trapped in the core, but with no plate tectonics to bleed that heat off the way Earth does. So the textbook said Venus sealed itself under a single stagnant lid of crust. It resurfaced the entire planet in one catastrophe hundreds of millions of years ago, then went still. A one-time event, long over. Finished. Then, in 2023, a scientist named Robert Herrick decided to check. He went back to the same Magellan radar. The data NASA had gathered when it mapped almost the entire surface of Venus, then left to gather dust for 3 decades. He started comparing passes over the same volcanic region taken months apart, by hand, for about 200 hours. In his own words, "I didn't really expect to be successful, but after about 200 hours of manually comparing the images, I saw 2 images of the same region taken 8 months apart, showing telltale geological changes caused by an eruption." 200 hours of squinting at old radar, and there it was. In February 1991, a volcanic vent near a mountain called Maat Mons was about 2 square kilometers. Roughly circular, steep-walled, a drained magma chamber. 8 months later, in October of the same year, that vent had doubled in size and filled to the rim with a lava lake. They ruled out tricks of the radar with careful modeling. This was real. A volcano had erupted in the middle of the Magellan mission, a live eruption caught by accident on another planet. We had the evidence on tape since 1991, and it sat there, unseen, for over 30 years. Then it got bigger. In 2024, another team, led by Davide Solcanese, went digging through the same Magellan data and found fresh lava flows. About 30 square kilometers at a volcano called Sif Mons, and more than 40 across a plain called Niobe Planitia. Flows so large that, taken with the Maat Mons eruption, they imply Venus may rival Earth in volcanic activity, a planet not winding down, but running. The flow at Niobe alone is enough molten rock to fill tens of thousands of Olympic swimming pools. And it erupted while we were filing Venus away as dead. So put it all together, the famous sign of life, if that gas is even real, is most likely volcanic exhaust. The planet was never whispering, "We're alive in the clouds." It was roaring, "I'm still erupting down here." Venus is not a fossil. It is one of the most geologically active worlds we know of, alive, restless, resurfacing itself in real time. And the evidence had been sitting in the archive the whole time. One honest caveat, that recent eruptions happened, is solid. Whether Venus truly matches Earth's full pace is still an estimate, drawn from a hand-searched sliver of the data. So we say it may rival Earth, not that it does. The discovery is young, which leaves one last uncomfortable question. If the answer was sitting in our own archives for 30 years, what does that say about us? Every paradigm-shifting Venus discovery of the 2020s, the strange chemistry, the active volcanoes, came not from a new spacecraft at the planet. It came from new computation, applied to data we'd had since the 1970s, 80s, and early 90s. The frontier of exploration this time wasn't out in space. It was a dusty server rack. And the neglect isn't even over. In 2021, NASA finally selected 2 new Venus missions, Da Vinci and Veritas, and Europe added a third. The press called it a coming decade of Venus. Then, in the 2024 budget cycle, Veritas was pushed back from around 2027 to no earlier than 2031. Its funding was gutted, its engineering team was disbanded. The 40 years of looking away quietly became 40 plus, in real time. We're still doing it. Because that's the truth underneath the title. Nobody hid Venus from us. We hid it from ourselves by deciding for 40 years that a dead world wasn't worth a second look. The data never stopped speaking. We just stopped listening. So, why did we stop going back to the one planet we'd actually managed to touch? Not because it had nothing left to say, because we'd convinced ourselves it was finished, and then filed the proof that it wasn't into a drawer and forgot to open it. A titanium sphere built to die in 32 minutes lasted 127. and then went silent on the 1st of March, 1982. That silence has lasted 44 years. Venus spent every one of them erupting in the dark. And only now, with the archives finally reopened and new probes, slowly, on the way, have we started to look back. If this rewired how you see the planet next door, subscribe, and I'll see you in the next one.